Welcome again, grade 12 students. For this video, we're going to cover lesson 5 of your practical research 2. This is entitled Finding Answers Through Data Collection. For the learning competencies, we have the following. 1. Collect data using appropriate instrument. 2. Present and interpret data in tabular or graphical forms. And 3. Use statistical techniques to analyze data. This is to help you craft your chapter 4, which is entitled Results and Discussion. So in chapter 4, we typically see the following components. We have tables, charts, and graphs. We also have the discussions of the results, the interpretations, and implications. Implications are included in order to support or refute findings of other researchers. So for data collection, you may use any of the following techniques depending on your or on the nature of your study. So you may use questionnaires, conduct interviews, or experiments. Questionnaires may be in the form of paper and pencil, by mail, or web-based. So depending on your resources or depending on your on the nature of your research, the use of any of the three types of questionnaires. Conductive interviews may be done by phone, face-to-face, or it may be computer assisted. So depending on the availability of materials or depending on on the nature of your research. So any of the or every technique has advantages and disadvantages, but the best consideration here is your study, the objectives of your study, what is most appropriate to answer your research question. So choosing the method to collect data is according to the nature of your research and according to how your research will answer your research questions. Or conductive experiments. Conductive experiments employs the use of scientific method. Remember that instruments are always according to how you will answer your research questions. For example, these are your research questions. So you craft your instrument depending on the questions you need to answer in your research. For example, you have the following research questions to answer, and the instrument you're going to use is a survey questionnaire. A survey questionnaire usually has 5 sections. We have identifications. As you can see here, we have the title of research, an introduction. So a short introduction, introduce the research, nature of your research to your respondents by at least giving the main objective of your research. An instruction, be clear on what you aim your target participants to do or to accomplish in your research. Information, provide sufficient information that they will not have confusions while answering or accomplishing your instrument. And classification data. Normally, a survey questionnaire have options already where they will just choose their response. So that's a typical survey questionnaire in a typical research study, especially for beginners like you. So these are some sample instruments. So as you can see here, we have, let's say you need to gather demographic profile of your respondents. So usually it is in the beginning part of your research. But of course, you need to um, let your students or let your participants know your study by giving the title and the main objective of your research. So you have to be clear with your instructions. So there, part 2, and then part 3, you tell them what to do, exactly do. So this one is generating a dichotomous data. So there are instruments that you will collect dichotomous data where your respondents will just respond yes or no, or degree of their agreement, or frequency, as always, sometimes or degree of agreement from strongly agreed to strongly disagree. And then in paper and pencil tests, when you need to determine a level of achievement, for example, or level of understanding or conceptual understanding. So normally we use paper and pencil research instrument there. Take note that research instruments must undergo validation before they can be administered or used for your data collection. Data processing. For data processing, this deals with editing, coding, classifying, tabulating, and presenting data through diagrams or tables. So after you have collected your data using any of the procedures that we have presented in previous slides, you are now ready to present them. So normally we use diagrams, tables in presenting the data. So give your readers a clear picture of what you have collected from your respondents, or as primary steps in answering your questions, research questions. It involves series of actions or steps performed on data to verify, organize, transform, integrate, or extract data in an appropriate output form for subsequent use. So as I said, this is to um, clearly picture or give your readers a clear picture of what you have collected from your respondents and how you will present this and interpret these results in your chapter 4. So the steps we follow are: 1, classification or categorization, which has been done even before you have administered your research instruments. Number 2, coding of data. 3, tabulation of data. So this uh, is done when you are already in crafting or writing your chapter 4. And then data diagrams consists of charts and graphs used to effectively present data. It's a pictorial representation of your data collected. Data interpretation is defined as an adequate exposition of the true meaning of the material presented in terms of the purpose of the study. So when you interpret your data that you have presented in tables, graphs, bar charts, etc., you have to stick with your research titles. So the main purpose of doing your research is to answer the research questions that you have set in the beginning part of your research paper. So in doing data interpretation, you must stick with answering those research questions, and take note that you are answering the research questions in chronological order. So results and discussion should be systematic. So in here you have to organize well your data. You interpret them accordingly, systematically, chronologically. Use terms that are easy to understand. Use transition words also, that it will look like you are telling your readers a story. It is telling them how you collected the data, how you are interpreting the data, how you are presenting your data, how you are answering your research questions in a manner that they can understand, that they will understand easily your undertaking. So it must be logical, comprehensive. You do not shortchange your readers when you are interpreting the data. Findings discussed in relation to literature and review and placed within the context of the theoretical framework underpinning the study. Discussion presented in the past tense already. So when you are writing your research results and discussion, be careful with using active voice and present tense and past tense. So in results and discussion, you usually inject a literature review. So whatever studies and literature review that you have gathered in the beginning of your research, you must be able to inject them here in data interpretation in results and discussion, because this is where you will refute or support data or results of other researchers. And this is also to strengthen your research, your study. So you have to be able to connect your results with the results of other researchers. We have 5 steps in data interpretation. Number 1, revisit the main and sub-problems. As I said, you have to stay focused on answering your research questions. Number 2, describe the data. So be able to describe the data according to how they are presented. Number 3, plan for data presentation. So you may use any means for as long as you can completely, comprehensively present your data. Number 4, plug in additional information. So it has to, it requires higher order thinking abilities or skills. You have to, do not just tell your readers about what they will see or what they can see in your tables, charts, or pictorial representations of data. You have to be able to discuss them according to how well you have researched about your topic, how well you can explain the answers to your problem. So you have to add more information that are sensible, that are significant for better understanding of your research study. And number 5, include closure or concluding statement in every data interpretation. So you have to conclude or close the each set of data interpretation. So before you go to answering, for example, the next research question, you have to conclude well your previous interpretation, and then you do this for with each of your research problems. So again, the data interpretation must be according to the order of your research questions. The following are common statistical tools in researches done by beginners like you. We have frequency count, pie chart, bar chart, mean and standard deviation for descriptive statistics. And then if you need to do hypothesis testing, usually we encounter in simple researches Pearson R, correlation, regression, Ttest, and Z-test and F-test, or analysis of variance ANOVA. Frequency count shows how many number of observations or the evaluation participants fall into various categories or categories of interest. For example, you want to gather demographic profile of students in a certain school. So they are categorized into different grade levels, different sections, or different gender or different abilities. You categorize the possible groupings of your respondents. So you can show this by using several means like pie chart. So in pie chart, you show the percentage of the groups or categories. For example, in this pie chart, you see the blue color, which represents the population of gas 11. So in your discussion, you have to mention that out of, for example, 1,000 participants you involved in your study, majority of the students or the respondents come from the grade 11 gas strand. So pie charts show percentage of responses or categories. We can also use bar chart. So bar chart, you see here the in example. So according to the height of bar, the frequency of students or respondents that were involved in your study. For example, the highest here is variable. So you see categories are well labeled, properly labeled. So across the x-axis we have the strands, and then y-axis we have the frequency. So in here we have intervals 1. So depending on the number of participants you have, for example, you have 1,000, you have to make use of intervals wherein you can have the y-axis in regular intervals to cover all the number of participants. For example, gas is around 600. So you choose intervals where you can present the data that is too far from or too varied to spread. Okay. Mean. Mean is also known as the average. This is the sum of all numbers divided by the number of cases. This is used to determine the overall trend of a set of data. For example, you are aiming to determine the overall performance of the students under each strand. For example, ABM, UMS, gas, STEM. So we have here, usually the presentation of means or averages are through a table. So we have here the means of, for example, GWA or overall performance of the students. So you can see here that among the 4 strands, STEM students performed better than the 3 other strands. So it provides a general trend of a set of data. Standard deviation, on the other hand, measures the spread of data around the mean or dispersion of data points. It indicates the degree of consistency among the responses. So take note that the higher the standard deviation, the more spread the values are from one another. The smaller the standard deviation, the more homogeneous or the less spread are the data. Like a mean, standard deviation can also be presented in tables. Standard deviations are usually presented with the means because, as you can see in the definition, it measures the spread of data around the mean. So for example, STEM here is of the highest mean. So this means that the overall performance or the average performance of the STEM students is better than those of other groups here, ABM, UMS, and STEM. Looking at the standard deviation, among the 4 that under STEM, standard deviation is smallest among the 4. So this means that the scores or the performances of the students under STEM strand are less scattered or less spread, meaning their scores are close to one another. The standard deviation 2.87 means that the average dispersion of individual scores around the mean or from the mean is 2.87. Gas has the highest standard deviation. So this means that the performances of students under gas strand is more spread, or the students are more heterogeneous. So standard deviation measures consistency. So this 6.15 standard deviation means that the average deviation of scores of students under gas strand deviates 6.15. The average deviation from the mean is 6.15. So this is high compared to that in STEM. Smaller, more homogeneous, less heterogeneous are the students under gas strand. Pearson R correlation is used to find out a correlation between 2 or more continuous, take note, continuous or scale variables. The coefficient correlation may be within the range 0 to 1. 0 means there is perfectly no correlation. 1 means perfect correlation. We have here a sample of the outcome when you run Pearson R correlation using your Excel or SPSS. So you will see here values ranging from 0. I guess highest is 0.8 there, 0.8, 0.867, and then we have the lowest, for example, 0.2, 0.2. Correlation varies from 0.0 to 1.0. The closer to 1.0, the higher the correlation. Correlation values may also be positive or negative. Negative correlation, it's like determining relationship between variables in your mathematics or science subjects. When it is direct proportion, positive correlation, it means that as one variable increases, the other also increases. As one variable decreases, the other also decreases. When the relationship is inverse or negative correlation in Pearson R, it means that the relationship is like this. As one variable is smaller, the other variable is bigger, or vice versa. So as for example, we compared here the overall performance average, that's GWA, average of the students, and then subject 1, subject 2, subject 3 to subject 8. Let's see the correlation between the GWA, or the average performance of the students, and their subject in the first subject, S1. So you just take a look at the intersection. So the correlation between the two, the coefficient correlation 0.867. So that's positive, meaning the higher their performance in subject 1 means the higher their average. So that's positive correlation. So as you can see here, the correlations are generally good, meaning all the subject account for or influence the average performance of the student. If your variables are nominal, your data is nominal, then you use chi-square test. If it's interval, then you use Spearman rank correlation. So all these are available in Excel and SPSS. Regression is used to predict the value of dependent variable, that's y, based on the value of two or more independent variables, x variables. The value range from negative 0 to positive relationship. This is like Pearson R, but this is used to predict the value or the effect of a variable, independent variable, to a dependent variable. You will see the outcome when you run this in SPSS or Excel, the following. So we have here the multiple R. The multiple R gives you the degree of correlation. So the higher the value, the higher the correlation between the X and the Y, meaning the Y variable is greatly affected by the X variable, or the independent variable. The R square gives you the percentage of the influence, or the the degree of prediction of the value of y to the independent variable, or x. So it gives you the percentage. So 0.75 means 75%, meaning the value of the dependent variable is accounted for uh, by the independent variable x by 75%. 75% of the value of the dependent variable is explained by the independent variable x. The remaining 25% is accounted for by other variables, independent variables. So in this case, you are comparing, for example, one x variable and the y variable. So that x variable influences the value of the y variable by 75%. So there's correlation between the two, 0.86, that's above normal correlation, and that is explained by the independent variable by 75%. The 25%, the other 25% is accounted for by other independent variables. T-test is used to test the difference between variables. This is used if standard deviation is unknown and the sample size is smaller than 30. We have two common types of t-test. We have dependent t-test when you have one group only, so you are comparing two means of the same group, or independent t-test when you have two independent groups and you test difference of between their results or their data. Z-test is used when the standard deviation is known and the sample size is big or greater than 30. F-test is used to determine or test difference between or among variables. If you have three groups, for example, in your study, then you make use of ANOVA or analysis of variance. We have several types of analysis of variance, but I'm sure you are more familiar or you have been oriented with one-way ANOVA, because this is typical for beginning researchers like you. So with one-way ANOVA, if you have one dependent variable and you have two or more independent variables. MANOVA means multiple ANOVA. This is ANOVA. When you have two or more dependent variables and two or more independent variables. ANCOVA means analysis of variance, one dependent variable and one covariant. MANCOVA means multiple analysis of covariance when you have two or more dependent variables with a covariate. So depending on your respondents, groupings, variables tested, then you choose any of from any of the four types of F-test or analysis of variance. Just take note that parametric tests are used to determine or to test a hypothesis and yield p-values. The use of parametric tests is based on two key assumptions. So normality and independence of observation. So we have here some samples of parametric tests and non-parametric tests. So parametric tests, we have one sample T or Z-test, two sample T-test, one-way ANOVA, two-way randomized block ANOVA. They have corresponding non-parametric tests. Which is better, parametric or non-parametric test? If you want a powerful results or higher degree of accuracy, then you use parametric tests. The criteria for use of parametric tests are more stringent than those of non-parametric tests, meaning non-parametric tests can be used to studies and give validity, provide validity easily. Unlike use of parametric tests where there is a higher requirement for use, meaning they provide more accurate results. The following are the steps in hypothesis testing. Number 1, state the null and alternative hypothesis. 2, choose level of significance. 3, find critical values. 4, find test statistic and drawing conclusion. For example, you have this question in your research. Is there a significant difference in the perception of e-learning between male and female students? So depending on your research question, the rest of the to address the rest of the steps in hypothesis testing. So first step is to state the null and alternative hypothesis. Null hypothesis is denoted by H sub 0. So for this question, for this particular research question, the null hypothesis shall be there is no significant difference in the perception of e-learning between male and female students. Take note that you are doing hypothesis testing for the purpose of rejecting null hypothesis. This is to strengthen your research study. And then alternative hypothesis denoted by H sub 1. For this research question, there is significant difference in the perception of e-learning between male and female. So again, the purpose of hypothesis testing is to disprove null hypothesis and accept the alternative hypothesis. For the second step, choose level of significance. The typical level of confidence is 95%. So the alpha level for that is 0.01. Though you can set more stringent level alpha level 0.03 or 0.01 for 93%, 97%, and 99% level of confidence. Critical values can be seen at the back, usually of statistics books. They are preset. So depending on the the statistical tool you are going to use, you will refer to. For example, Ttest, then you look at T-table, C-test, Z-table, F-test, F-table. So depending on the level of confidence you set, for example, 0.05 alpha level, then you look at the T-table under 0.05 alpha level. Fourth step is to compute for the t-value. So since you have had your statistics class, you are expected to have known how to compute manually t-value, z-value, and f-value. For the conclusion, it depends on the values of critical and test statistic. If test statistic, that's step 4, is greater than the critical value from the table, then you can reject the null hypothesis. Otherwise, you cannot reject the null hypothesis. So that will be all. If you need to study further about the topic, then you can search the internet, check YouTube and other resources. So that will be all. I hope you learned something from the video and are now ready to craft your chapter 4. That will be all. Thank you for watching.